Good morning, everybody. Should we finish up those titanium parts today? I'm hoping we can. I left the mill running overnight last night, and there's actually a setting where it'll turn itself off when it's done. It did turn itself off. That means there was no alarms, and our part is probably good. I came over here to turn on the air compressor, but it's already open, so we'll drain out some water. Yes, I know I should get an auto drain for that. The stainless job is still stalled until we can get a new blade for the bandsaw. I ordered it from McMaster yesterday. It should be here. McMaster orders unfortunately get here a little bit late in the day, so we may not see it until like 5 o'clock. But we don't have that much left to cut right now. Also, somebody mentioned that I should flip this 90 degrees to cut it. And yes, that probably would be faster. The only reason I didn't is I was worried about the blade drifting because I knew the blade I had in there was dull. The duller the blade, the more drifty they get. And this way it only has like an inch to drift. If I cut it this way, it would have 4 inches to drift. Somewhere in here, is this one? Yeah, okay. I have this piece of material. Oh. This is a piece of material I cut the other day. I think this is actually what dulled my blade because it was titanium. But if you look, it drifted a solid 1/8 of an inch, and I almost lost my entire bar of material because of that one cut being off. So that is why I was kind of paranoid about the blade drifting, and I chose to cut it in the orientation that I cut it. Let's get our warm-up started again. Hopefully we don't have it turn off like it did yesterday. All right, I'm gonna have to start getting selective about what I film here because I can't show you the part. But you can see over here in this scrap material, it's still attached. It's neatly held down by the tape. I did definitely eat into some of my hot glue, but that's fine. The biggest thing that kills these super glue work holding setups is the edge starts to peel. Now, if we come around to the other side here, you can see that we did actually start to get a little bit of grabbing, I guess is the term, here, but I think actually our hot glue helped save it because it like got underneath there and prevented it from lifting more. My biggest worry on that part, besides throwing the part off the fixture, was that it wouldn't be perfectly centered on the stock. The stock was only about 50 thou bigger than the part, so I had 25 thou on each side. That's about 0.5 millimeter for you metric folks. And there's just not a lot of wiggle room if something went wrong or if there was a crack in the edge of material or a rough cut. But it's fine. It was centered enough. The material was in good shape. It was sheared, not like saw cut, which tends to give you a straighter edge but causes warping. And so that should be good. I'm going to take some, I'm going to do an inspection on it for what I can reach so far so that if I need to like open up a bore, I can do that before I move it. And then we can flip it over. Well, first we need to make a fixture for the other side, and then we can flip it over and finish off the back side. And actually, first, I took a new zometry job yesterday, so we need a new process bin for it. I'm putting the certs, the traveler, and the drawings in this bin, and I'll have it queued up here waiting for its turn. I keep getting ahead of myself. I don't actually have a drawing of this part yet, so before I can check it, I need to make a drawing. And I'm just going to go ahead and warm up the spindle while I'm doing that drawing. The drawing is done, and I'll be able to get the part inspected as soon as the mill's done warming up. I mean, theoretically, I could do it now, but I don't want to, risk losing my hand. Let me show you something I've been working on. So you may notice all of my measuring tools now have a serial number on them. Generally, the first 2 letters say what it is. So in this case, M for micrometer, 1 meaning it's a 1-inch micrometer, and then it is my 1-inch micrometer number 1. These are calipers, 6-inch number 1, and then in here I have caliper 4-inch number 2. If I can open it, there you go. See, and there's the calipers. In here, caliper 4-inch number 1. And then in Airtable, I keep track of my calibration checks for each instrument. So I have which gauge I checked, what standard I used to check it, the target value, the actual value, if it's go or no go, and the error. My current plan is to check them every 2 months. Maybe I need to do them every 90 days. Maybe I need to do them every 30 days. I'm not sure yet, but we'll start with 2 months as the good compromise between those two. And if I have any instruments that are not for checking parts, for example, these calipers that I only use to check parts going on and off the saw, I have these labeled as for reference only because those are never allowed to touch a customer part. Well, touch a finished customer part. They're allowed to measure the stock for the saw. Yesterday I ran a few fidget cubes off camera, and while I would like to keep making these, I need to go back to carabiners. Remember that broken tool yesterday? That has left these carabiners with some really bad burrs on some of them. So I'm going to take the ones that have the burrs and clean them up with my Scotch-Brite wheel before I put them in the fixture. While I was deburring the parts, I heard the machine finish, and it finished normally. It didn't do the slow wind down that it does when it runs into that contactor issue. But the machine turned itself off. Turns out you need to turn off the power off at M30 option, or the machine will just decide to take a nap on you. But it's still warm even if I had to power cycle it. So we can check that part and then continue with the other side. Okay, we had some interesting results from my measurements there. My part basically looks like this, so we're going to use this as an example. So almost all the measurements, like the width of this thing, the length of this thing, and the width here, those were all 2/1000ths too big. And I think that was due to tool wear. We did a lot of material removal in titanium at probably too high of a surface feed. So 2/1000 of tool wear is not unusual for what we just did. That's fine. The weird thing is this measurement here was like way too big. It was like 5/1000 oversized. And I'm not sure why. I think it may have been due to like the tool chipping funny, or maybe a funny burr or a corner radius on the tool, and it was just hard to measure with the calipers. I don't know. But what we're going to do is I'm going to switch to a different tool, a sharp tool that does not have a corner radius, and we are just going to go all the way around again and see if we can dial in all the various features. I bet this dimension here that was way too big will resolve itself, and these dimensions here that were within like 2/1000, I think I can slowly dial in using wear comp. All the other features used fresh tools, and they were pretty much bang on. There was a hole that was about 8/10 oversized. There was another hole that was 2/10 undersized, but we have plus or minus 5/1000 on this part, so that's, within a mile. I don't know what within a mile means. What I mean is our tolerances are huge compared to our error. We have a mile to spare. All right, I'm going to turn on single block. I'm going to turn down rapids. I'm going to turn down our feed just a bit here. And now we can prove out the program. The position looks good, so we're going to turn off single block and hit go again. Yep, all right, it's doing a good job. And while that's running, we can get the Tormach loaded up to run the carabiners again. We're going to do the backside chamfers on these. That's the only part that's happening in this operation. This is a dedicated fixture for the carabiners that I should have cleaned out. They just fall into some pockets here. They sit in some pockets and then get screwed down. All right, I just checked it again. And we are dead nuts on this feature here. We are dead nuts on this dimension, but we're still 4/1000 oversized on this way. And I don't like that. That doesn't make me happy. I don't know why it's just that one direction. Maybe thermal expansion. My machine might still be cold. That's the best guess I've got right now. But what I'm going to do, and I don't like this because this shouldn't have to be done, but I'm going to take off just a couple thou on this side. That may shift the relative position of some of my features, but I am just taking off a tiny amount. I'm going to take off 2 thou, and so it shouldn't put anything out of tolerance. And yes, technically right now my part is in spec. It's within my plus or minus 5 thou, but I aim for my shop tolerance is plus or minus 3 thou. So it doesn't matter that it was quoted at, or Xometry says plus or minus 5 thou, and that's what it's quoted at. I do plus or minus 3 thou, unless the drawing says to do it tighter. Is that technically waste that I'm spending time on getting some bonus tolerance that they don't care about? Yes, I suppose I am wasting time and money doing that. However, a part was never rejected for having its tolerances being too tight. If I mismeasure something or the customer measures something differently, and I measure it as being a thou on the right side of the tolerances, and they measure it as being a thou on the wrong side of tolerances, that's still an unhappy customer. So by aiming for a tighter tolerance than Xometry calls for, it's just some insurance that I don't miss anything dumb for dumb reasons. Plus, it makes me a better machinist. Okay, the part check's good. Now we can get that thing out of there and move on. Now you may be asking yourself, how do we get this part off? I particularly don't want to damage it or warp it at all. Paper here for redaction reasons. This is plan A. This is a thoroughly deburred paint scraper. I have made sure there is 0 sharp edges on this thing anywhere, and you can generally get underneath parts, and if you're careful and you work them around, you can kind of pop them off. If this doesn't work, then we will go to something that gives us a little bit of heat. And if that doesn't work, then we can go to some more dramatic options. But I think this will work here. To reduce some risk on the next step, I just went ahead and brought the part over to the bandsaw with my portaband, the little one. And I removed some of this extra material here. It just basically gave me these little pieces of titanium foil. And I can, for example, take some pliers here and just kind of bend off some of these loose edges. Just anything that might grab the end mill on the next step and tear the part out of the fixture. Obviously, you have to be really careful when doing this stuff because one slip could scrap your part. So pay attention to what you're doing. So for the next step, we're going to do super glue work holding again, but we're not going to be using this fixture. We're going to take that off, put my vices back on, or at least one of my vices, and we are going to make a custom fixture out of this big piece of aluminum, which I'll have to cut with my bandsaw broken, so that'll be fun. This will be a pretty simple setup. We're going to do a pocket in this piece of aluminum. We'll put super glue in that and then push our part into that pocket. The pocket will provide both lateral support, but also, and more importantly, it'll locate that part. Whenever you're fixturing something, you're doing 2 different things at the same time. One, you are holding it so it doesn't, go flying away or it doesn't cause chatter. And then 2, and this is the difficult one, is you're providing location for that part, i.e. your machine needs to know exactly where the part is. And you can do that by putting your part in a vise and then probing it, or you can have a fixture where the location is baked into the fixture. Super glue work holding does a really good job by itself at just the work holding part, but it does not do a good job at the locating. But kind of like putting soft jaws in a vise, you can do a quick and dirty little pocket fixture, and that provides both of them. So now we need to get my vices put back on the table here, or at least to one of them. I'm going to put my Saunders Machine Works mod vices back on, and I'll put my flux vise back on later when I need it again. I've been using these mod vices for a couple years now, and I have to say, while they're not the best at anything, there's nothing that you can't find a better vise for, they do everything pretty darn well, and they're definitely not too expensive. So I wouldn't recommend these for all applications, but if someone's just getting started off and just needs a vise to get them started, it's a pretty good way to go, especially considering they're cheap if you already have the fixture plate. Now, obviously, the fixture plate itself is not exactly cheap. But if you already have one of those and you're just getting started, a mod vise will do just about anything and everything that you need. Now, hopefully, I have enough room with this plate here. So, this is a piece of scrap that's the same size. Do I need to move my... I should have checked this first. All right, we need to shift that way some. Or rotate. Yeah, probably shift that way some. That being said, I actually have a brand new vise on the way to replace my Saunders vices. It won't be quite as flexible as these, but it should be a lot faster for the kind of work that I'm doing. And, at this point, I know what my niche is. And so I don't need one vise that'll do everything. I need a vise that'll do exactly what I need, and, you know, no more. That fit there. That should go there. So I'm really excited for that to get here. I'll show it to you when it comes in and tell you why I bought it. But it is both cheap and should be a nice upgrade for me. The other vices that I currently use are these flux vices, and I have two of them. They are the best vise for Op2 work. They don't do Op1 work very well, but they are fantastic for Op2 work. Actually, let me clarify. They would be perfectly fine for Op1 if you were doing production on a part. I don't do a lot of production work. I just do like job shop style work. And with the job shop style work, you want a more universal vise for your Op1s. But for Op2s, you cannot beat those flux vices. There were most certainly better ways of doing that. Now we can get the plate loaded in here. Kind of having to balance the location of the tool setter and our work area. We obviously don't want to leave the work area, but we really don't want to hit the tool setter. Yeah, that should be good. Maybe a little bit more. These white borders here, that indicates the edge of my work area. This is not a big machine. This is, in fact, a tiny machine. My Tormach has far larger travels than my Haas does. But the Haas weighs twice as much, which is why it's just a better machine. And also, when the Haas was new, it probably cost 4 times more than the Tormach did when the Tormach was new. So there's that too. All right, now we need to set our work coordinate system on this guy here and cut out a little pocket that our part's going to sit on. We don't need to be dead accurate here, so I'm going to do this in this 1000th step mode. When I want to be more accurate, I do it in the 10th step mode. So turn on the spindle, jog, move slowly until it pops out. Okay, I went too fast there. Let's go back up, move slowly. Pop, okay, I'm going to set that as my offset. This is G55. Alright, let's go find our Y. And do the same thing. Sometimes it's easier if you give the wiggler a tap so that it, you know, wiggles. Then we can do the thing again. There we go. Part set 0. And turn off the spindle. Do you know what the scariest part of this machine is for me? And I've never actually tested to find out if this happens, but the tool release button is right next to the part set 0. And I'm terrified of hitting this when I mean to hit this and like dropping the tool while the machine is running. I would like to believe that it would stop you, but I don't know, and I don't want to test. So now we're going to switch to the tool that we're going to use to set our Z height. This also happens to be the tool that we're going to use to do the majority of the material removal down here. And we'll just kind of jog this to the middle-ish. Slow. Alright, switch to the 10th jog mode, and now I use a piece of shim stock. Sorry for the great view. I can use a piece of shim stock. This is, I know, 2/1000ths of an inch, and we're going to kind of slowly go down until it starts to grab. So there's a little bit of friction. And there where it's really grabbing, that'll be our tooth. Back in our offsets menu, I can hit part set 0, and there's our Z offset. Though now we need to shift everything by half the diameter of the wiggler and then by the length of this tool. I drew a cheat sheet up here for which direction, so I know that I'm touching off on this corner, so we need to go X, plus 0.1, and then Y minus 0.1. And then for the Z, we need to subtract 0.002 for the shim stock. And then we have to subtract the tool length of the tool that we used to touch off, which was tool number 3. So in this offset menu, I'm going to type negative 2.9648. You see it like stores it down here in the bottom corner. Then I can go back to this offset menu and hit enter. And then yes, I want to make that change. And there is my correct Y offset for this part right here. This is our fixture here, nothing too crazy. We basically have a nice little pocket that the part can sit in. There's a couple holes to help with location and some meat on both the sides. Now, unfortunately, our part is really, really close to the size of the only stock I had on hand for this fixture. There's not a lot of meat here, and I'm kind of worried that I'll just have to cut that all off. That's the only reason I bothered with these locating holes. Normally, I wouldn't. Normally, I would not put interior holes in a fixture like this, but because I didn't have much meat on the sides, I thought it might be worth it. And honestly, maybe even just this little locating feature here with the back wall and this wall might be enough. We'll see how it fits once I get everything put together. The cam is exactly what you should assume it is. We do an adaptive roughing, then we come back in with a flat tool path to finish the floors, and then a 2D contour to finish the walls, and lastly a deburring tool path. Good news and bad news. I just did a test fit of the part, and it fits in here and it's a little bit tight. I used a hammer to see if I could seat it down a little bit more, and in the process of that, I moved the piece of material here. I moved my fixture a little bit. It's probably not much. It probably wouldn't matter because I was able to push it right back down. But, oh, you never know, and I don't want to scrap this piece of material. So we're gonna recut our fixture just slightly lower. Saw blades here. You're not going to be able to tell on video, but this is going way faster than it was before. I also got a blade with a lot fewer teeth, so bigger teeth and less of them, and that seems to be helping. All right, so now this fixture is finally ready to start working on the super glue. No tape on this one. I will scuff up the surface a little bit. I am not going to scuff up the part surface. Nothing too crazy here prep-wise needed. The pockets provide enough support that the super glue does not have to be perfect. It just needs to be, good enough, provide a little bit of work holding. So I'm gonna just kind of scuff this, and then I'm gonna clean this with alcohol and clean the part as well. So first off, you don't want any weight on your part because you want it to be machined in the relaxed state. Second operation, you want weight on your part to make sure that if there is a little bit of warp, your part is at least parallel. So first op determines flatness, second op determines parallelism, unless you screw something up like getting the chip underneath there. So the new saw blade is doing a great job. That's a really nice looking cut. The old cut does actually look pretty similar. Like the old cut wasn't bad either. There's the old cut, there's the new cut. Off camera, the new cut is definitely shinier and it's a little bit more square. It's also like 5 times faster, and that's the biggest difference. So I just need 9 more of these pieces, plus maybe one setup piece, and then I'll be done. I'm gonna be very patient with this as the glue is curing. I'm gonna give it at least half an hour, maybe 45 minutes, just to make sure. I did not use activator on this, which I normally do, but I found on second ops, you run into risks of it curing before you get everything situated. So no activator on the second ops. Just patience, which is unfortunately a little bit more expensive than activator. But I have plenty of cam work that I need to do, so I'm going to get started on that while it's curing. It did not work. This corner here is still stuck up a little bit. There's some like gaps in the side of the fixture here. They were just clearance for the radius of the end mill. So I can actually see where it's pressed down and where it's not, and it is most certainly not pressed down in that corner, which I think means I need to restart and glue it again. The biggest bummer is that was the last of my super glue, so I'm gonna have to go out and buy some. Turns out the glue wasn't actually quite cured, so it's maybe a good thing I didn't run it yet. Getting the glue off the fixture is easy. I'm just gonna take some of this activator and make sure that it is all cured. And then once it's done, I'm going to rerun the finishing passes, and that'll just cut all the glue off. So this will just take a minute to run, and the part I will just soak in acetone inside a glass container. Let's get this part cleaned off. We'll get it soaking for a bit here. It's probably way more acetone than I need, but that super glue will come off in a bit. I am having issues. I'm having a hard time making sure that it's in here flat and parallel. I noticed that it was a little bit popped up in that corner again, so I used a little bit of force to move it, and I think the whole fixture moved again on me, unfortunately. So I'm going to take this back out. I'm going to recut the fixture again, except this time I'm going to put actual parallels underneath it instead of the mod vise jaws. I think the mod vise just does not have enough force to grip this thing and to keep it from moving on me, which is very frustrating. The mod vices are designed to be 1 inch off the ground when you're using these serrated jaws. So by putting 1 inch parallels in here, we should solve our tilting problem. It took me not 1, but 2 attempts, and this thing is finally in place and we can run the program. All right, I was hoping to close the loop and tell you how this went, but I think I need to edit the video and well, I was hoping that I would be able to close the loop on this project today, but I'm out of time. I need to edit the video and get it posted. So I guess you'll see next week. Tomorrow? Whenever I post a video next.